Hello class 9. Today we are going to discuss about spherical mirrors. Let's say that there is a sphere of glass, and if this sphere is cut out this way, then you'll get a portion of the sphere, okay, which looks like this. And if the inner portion is silver coated, okay, the line shows over here that it has been silver coated from this side, then this portion, the outer portion, will be the reflecting surface, and the reflecting surface is which is bulging outwards. Okay, this is bulging outwards, and this is the reflecting surface. Then this kind of mirror which is formed is called as convex mirror. Similarly, if the same piece of sphere is silver coated from outside over here, okay, then this portion will be reflecting surface. Then this mirror looks like it is curved inwards. Okay, if it is curved inwards, then the mirror formed will be called as concave mirror. Concave means it is curved inwards, and the bulging is convex. All right, so now this is the mirror mm dash, okay, and this is the center of that sphere. Okay, this is the sphere, the actual sphere that we initially started with. It was cut out and this portion became the mirror. So this is the center of that sphere, and for this mirror, this is called the center of curvature. So center of curvature of a mirror is the center of the sphere of which the mirror is a part. Now, from the center up to the mirror, up to the point of the mirror over here, P, this distance is the radius of the sphere. Okay, and hence for the mirror it is called as the radius of curvature. So the radius of curvature is the radius of sphere of which the spherical mirror is a part. Next, now you can see that this P is the point which is the center of the mirror. See, this is the center of the sphere, and if you are only talking about the mirror from here to here, this point P will be the mirror, the center of the mirror mm dash. So point P is called the pole. Okay, so geometric center of the spherical surface of mirror is called the pole of mirror. From here, from M to M dash, all right, this portion of the mirror is the actual mirror. Okay, if the light falls on this surface, then it will be reflected back. All right, so this portion is called from here to here, where the entire mirror you can see will be called as the aperture of the mirror. So the aperture is the plane surface area of the mirror in which light rays fall incident. Now you can see the straight line over here. Okay, straight line from pole, and it's passing through the center of curvature. So what is this line called? It's called the principal axis. So the principal axis is the straight line joining the pole of the mirror and its center of curvature. Okay, so this is your principal axis. Now here we have some of the terms that will be quickly you can refer to at this image. See over here, this is painted from outside, so this is a concave mirror, and this is painted from inside, so this is a convex mirror. All right, so this is aperture, okay, center of curvature. You can see whatever we have discussed earlier. So this is just a quick reference for the things that we have learned just now. Next, suppose if you have a concave mirror and there is any ray of light which is incident on the surface of the mirror, then according to the laws of reflection of light, there should be a normal at that point for that mirror, okay, and whatever angle it makes, the angle of the incident ray mix the some angle with the normal, according to that it has to follow the rule of reflection, the law of reflection, and then there will be the reflected ray which again forms the similar angle. All right, this means that simply that this angle of incidence needs to be equal to angle of reflection. So if the angle of incidence is always equal to angle of reflection, then it is true in this case also. Then any reflected light which is incident at the surface of the concave mirror, then it gets reflected following the simple laws of reflection. Okay, so here this is a simple reflected ray, this is the incident ray, this is the angle of incidence and the angle of reflection. Similarly, if there is a convex mirror and any ray of light is incident on the surface of the convex mirror, then there will be a point from here. If this is the center of curvature, then from that point there will be the normal drawn, and since this is a simple reflection in the curved surface or the curved mirrors or the spherical mirrors, then again there will be the light reflected, making the angle of incidence equal to the angle of reflection. So this is how the lights reflect. And suppose if there is a concave mirror in which there are parallel beams of light which is parallel to the principal axis, these rays of light are parallel to the principal axis, okay, then the lights will reflect following the simple law of reflection this way. Okay, the first ray will bend, will reflect, second ray will also reflect this way. All right, but surprisingly all these reflected rays will pass through a certain point over here, and this point is called the focus of that mirror. Okay, and if this is the focus of the mirror, then the distance between the point focus up to the mirror or up to the pole of the mirror, we can say this distance is called the focal length. So we can define focus as the focus of a concave mirror is a point on the principal axis through which the light rays incident parallel to the principal axis pass after reflection from the mirror. All right, so you can see that all these rays are parallel to the principal axis, and when these parallel rays of light which are parallel to the principal axis always passes through the point, okay, they will intersect at the point, and that point is called the focus. All right, next, the focal length. The focal length of the concave mirror is the distance between the focus and the pole of the mirror. Now if we take a convex mirror, okay, and similarly if the rays of light which are parallel to the principal axis are incident on the surface of the mirror, then simply following the laws of reflection, the lights will start to bend, or sorry, the lights will start to get reflected this way. Okay, now these rays of light are reflecting, but if we trace its path backwards, then all these rays appear to come out, okay, from this point. So this point will be called as the focus for the convex mirror. Okay, and the distance between the pole of the mirror, this point, to the focus the distance between the pole and the focus will again be called as the focal length. So the focus of a convex mirror is a point on the principal axis from which the light rays incident parallel to the principal axis appear to come. Okay, remember this is the key word, appear to come after reflection from the mirror. Okay, it's not actually coming from that point, but it appears to come from that point. All right. And the focal length of the convex mirror is the distance between the focus and the pole of the mirror. Here we can see in this image that this is a concave mirror. Okay, so its reflecting surface is, curved inwards. So if any parallel beam of rays which is not parallel to the the principal axis, if any parallel beam of rays not parallel to the principal axis gets incident on the surface of the mirror, then it will come and the reflected rays will come and intersect at a point. Okay, it may intersect at any other point. It may intersect at the focus if it is parallel to the principal axis. If it is not parallel to the principal axis, then it may intersect at any of the point within this line. Actually, this is not the line, it's a plane. Okay, so within this plane, wherever the light rays can intersect and the focus can lie on that plane, in any part of that plane. All right, similarly over here, the convex mirror, any parallel beam of rays which is not parallel to the principal axis may, after reflecting, may appear from any of the point lying on this plane. So this plane is called the focal plane for the mirrors. Okay, this is the focal plane for the concave mirror, and this is the focal plane for the convex mirror. And for the convex mirror, the focal plane lies inside the mirror, okay, which is actually not the real focal plane. In this case, it's the real focal plane, and in this case, it is not real, it is virtual focal plane. All right. So from here, the lights may appear to be diverging outside, and here the lights totally intersects and forms over here. Okay, so the focal plane is a plane passing through the focus and is perpendicular to the principal axis of the mirror. So this is the definition. These are the terms and terminologies that you need to understand for the spherical mirrors. Okay, so there is an assignment in which you need to prepare notes from the from this video, whatever you have learned, the definitions of the terminologies. Okay, please make a note out of it. All right, thank you.